Today, we're going to ask a TeslaBot expert a number of questions to dive deeper into understanding what is TeslaBot's biggest lead or advantage in terms of hardware as compared to how others are doing it. What is TeslaBot's battery life? How does it compare to everyone else? And what can a 22 degree of freedom hand do that an 11 degrees can't? How does Optimus compare to Figure? And what about Digit? Scott Walter is an aerospace engineer with a Ph.D. in mechanical engineering and has co-founded two robotic companies. Welcome, Scott. Thank you for joining me again.
Hello, Herbert. It's nice to be back.
So one of the things I wanted to do today is dive much deeper into TeslaBot. They had to make some design choices because they want this to be a generalized humanoid robot that's going to do a lot, like every task. Normally, when you create a product, it's very, very specific. So let me show, for example, Digit. Let's compare that right away to that. And Digit, they purposely created their bot to be this tiny little bot. It's got this, different kind of leg so it can kneel down further. It's really designed for pick and place. Now, of course, in this demo, they're showing a home and a kitchen, but that's not what this is for. This is for a factory. And so they decided to go this route, very thin, very small. I don't even know where the battery goes. And they don't have hands. They have these grippers that you could change out the grippers, but they're meant to be grabbing packages, moving them from one place to another. But the TeslaBot, it's designed for general purpose, right? So oops, let me take that off. Of course, everybody's seen this now. And so what I'm asking is what are the design choices that Tesla had to do?
Okay, so a lot of it is making a decision of how far you want to go into the humanoid form. And if you compare the two companies and their approaches, Agility was starting out literally from the ground up. They built the legs to try to understand bipedal walking and then wanted to figure out what do we put on top of it? What kind of applications do we put on there? So in some cases, they weren't integrating the whole thing or limiting themselves to whatever was the best fit application. And so the logistics market they're going into is a huge TAM. I think we've been told it's like somewhere around 1 trillion boxes get moved around the planet every year. And so there's a lot of logistics that's going on. So just that niche market itself will keep you very, very busy. So you could design a mechanism to go in there that doesn't need to have the full flexibility that you would expect to see for general purpose bots. So you can see there aren't fully formed hands there. The legs are maybe a little bit different. One of the first markets they were looking at was basically, I wouldn't call it the last mile delivery, but basically the last 100 foot of delivery of going from the curb to the doorstep and figuring out how to get a bot to be able to do that. So the requirements for that would be very, very different. Kind of dexterity you have in your hands could be very, very limited. The battery life might be a little bit different, but you maybe have these other needs of being maybe more compact and portable as you go from one location to another. So they're all, are working with different design constraints depending upon what kind of focus you have and where you want it to be. But in the end of the day, they're all trying to figure out how to get useful work out of these things. So that's what's really limiting your design choices. So can it do the task that you want? Can it do it reliably enough? Can it do it long enough? And can it do it for a cost that's less than whatever the traditional way is? And the traditional way may be replacing an existing form of automation that you already have in there, or human labor that's in there, or a combination of both.
Okay, but I guess my question is, Digit, very clearly from my mind, they looked at a very specific task. And when we spoke to the executives there, they told us that that is what they did. They didn't think of it humanoid first. They thought of it as, what do I need to do pick and place in a warehouse? And that's why they went off they decided that the knees had to be bent backwards so they can even bend down even lower, or whatever other use cases they did. But is a TeslaBot going to be able to do the pick and place if they've got this incredible hand that's got 22 degrees of freedom? It's got the touch sensors. I mean, just like a human, we can do pick and place certain amounts. But I guess, are they going to lose if there's a very specific job of just pick and place? You know what I mean? Like, if you create a bot that is general purpose, the risk you have is that it's not great for certain tasks.
Yes, exactly. So general purpose is not specific purpose. So you may lose out in some of these niche markets, but you have a much wider market to go in. So you won't be, you still will be able to do the task. The question is a little bit of overkill for that particular task. And in some cases, the idea that if you have something that's very specific purpose, then you should be designing automation kind of for that specific purpose because it doesn't change very much, or the parameters are very, very small. But if you look at a lot of workers that are in a factory, they don't do the same job all day long. They're doing different ones for short periods of time. And each one of those will require a different level of sophistication or dexterity or skill to be able to do it. In some cases, you don't need your full hands. In other cases, maybe you do. And so that's where the general purpose, or let's say, the general purpose comes in, is because it gives you the flexibility to deploy the asset where it needs to be at that time. So yes, there may be days where it would be best to not have a robot that has full hands because you don't need it, but maybe that's for a short period of time. And suddenly there's another day that you need something with full capabilities. So there are pluses and minuses to that. In the end, if you're able to scale these things up and get the cost down, and if it costs close to the same, then you may as well go ahead and have the full features in there, especially if you're going to be using it. But I agree, if you are never going to use that capability, then you might want to come up with a version of the bot that doesn't have complex hands, but has something that's a little bit simpler, assuming that that bot is also still as capable as the other one, beyond just being able to pick up the box, but having whatever sort of algorithms are going to be needed to go in there to walk quickly, to place it down, because there could be a lot more than just needing to have hands, but also thinking about how you're able to walk about. Are you able to walk quickly? Are you able to pivot? Are you able to put it into areas that are a little bit difficult to reach? So a lot goes into it. And since we've designed many applications already around the humanoid form, we should expect that a humanoid bot probably will be a reasonable solution to that particular problem.
And here's an example, right? So here's a BMW factory. You got all these humans walking around. Doing things like plugging things in. The Digit bot can't do this. Digit bot is only very specifically for pick and play, so they might be better for that very niche thing. But all these other things like this, the humanoid bot should be, as you're saying. I'm just worried that if you're designing for general purpose, you may not be, okay.
Now, if you look at this, the tooling that's there is specifically designed to be used by a human operator.
With that hand right there.
All the hand grips, the handles, everything is specifically for that.
That grip.
And now,
right
what
there.
this means is that you can easily come in and replace it with a general purpose humanoid bot because the form factor and everything's the same. Now, if you were to say, well, we are going to take the humans out completely, they're never going to do that task again, then you might sit back and say, well, maybe that piece of equipment we can redesign so it works for a bot that doesn't have fully formed hands. You could take that approach, and maybe that's where you go down further on down the line to say that things are being modified. But the idea right now is we don't want to change the environment to fit the bot. We want the bot to fit our environment right now, so we don't have to do the re-engineering and everything else. It's a one-to-one swap out, and it's only when you've decided that the bots are so darn good at these jobs that we'll just go ahead and start saying full automation, and then you will see slight changes. So for instance, right now, we still have to have all the safeguards up, or all the safety fencing and everything else, because these are cells that humans are able to go into. But once you fully automate it with a bot, you might be able to take away some of those safeguards. So the tooling might still be the same. You don't redesign that because it's pretty expensive to redesign all that tooling and get it to work right. But there may be other costs you can drop that you'll be able to do. But then once you make that step, it's really hard to go back.
Yeah.
You get a lot of sunken cost in that. And again, if you look at any automotive plant right now, all the spot welding, which used to be done manually, 4 or 5 decades ago, you can't do that anymore. You just can't go in there and take the gun off the end of the bot and start going around and doing it manually, because the whole cell and everything is designed for the industrial bots and the industrial bots only.
Okay. So that's, comparing it to Digit. Let's compare it to 1X. So you and I interviewed Bernd Bernich. He's created 1X. And what he said that surprised all of us is that he's going direct to consumer. He's going to go right to the home. He actually has a beta program now. I raised my hand, says, please send me one. Love to beta test it. But when he started talking about his bot, it started to all make a lot of sense. Okay. Because he said, well, if you think about the home, first of all, the reason he's going after home, he said, is that he's never heard of any revolutionary product ever that came from the enterprise and trickled down into home. It's almost always a consumer home first approach, and then it goes into enterprise. And so he's designing for the home. And so if you're designing for the home, look at this. You know,
Now form a dough. Divide the
people
dough
used
into two
to,
halves.
we would laugh at this, right? Because it looks funny.
Mhm.
It looks like it's just a person in a costume. It just doesn't look, cool. Like the metal bots that we're seeing here. It doesn't have the hands grippers. He did say that this is Eve, and this is the older generation. The one that's going to go to the home is going to be Neo. It will be humanoid. It will have hands. It will have feet. But he said what? 66 kilograms. It's very important for them to have it so light.
Oh, 66 pounds.
66
like
pounds.
30 kilograms.
He talked
Yes.
about how they don't want to show you what's inside yet, but they think that I think he insinuated that it's not actuators, not metal actuators, that it's actually tendons. Because again, if it's at home, it's going to be handling elderly people, home care. It needs to be soft, cuddly. So at first, people would laugh, oh my God, how ridiculous of this. But now you understand this makes sense. So if they are designing it for the home and they got lots of little features, how does the Tesla bot? Do you think the Tesla bot will be something that can be used for the home if it's, look at that metal? It's, it's just this, you know what I mean?
It's a bit more rigid,
Yeah.
right? But at least, the outsides are plastic and a little bit softer. And it's definitely heavier than the 1X because this is about 120 pounds versus 66 pounds. So there's a huge difference between them as far as weight. But the dexterity is going to be very, very close and similar there. Part of the weight reduction that they're able to get is probably where they're mounting the actuators and how they're doing the actuation, which we suspect is like through some sort of cabling mechanism in tendon drives. And also the fact that they only look to operate for about an hour at a time and then have like about a 5-minute recharge. So they're not looking to have an 8-hour battery pack. So if you reduce that, that's also a lot of the mass that will go down. The other thing that surprisingly they've done is like, after doing this, you would think they've been so successful. All you need is a 2-finger gripper and everything can be a mobile base its own wheels. And their next one is like, nope, we're using legs and we're going to have fully fingered hands in the next version of 1X because they've seen what the limitations are. And I guess one of the limitations you would see is that it seems like wheels would be a really great way to be able to get around the house. Why not? Because this is working. And I say, I challenge anyone, take a Segway and use that to go around your house. And how successful you'll be.
Right.
You'll find there's a lot of places you have a hard time getting into because the wheels are too wide. And if you want to lean forward to get something, it's really easy to kind of fall over, which is something that you would like to avoid and not have happen. And that's one of the things he's pointed out is that he sees legs not so much as something used for walking, but actually for manipulating the ground. It's a really interesting kind of concept because he sees that's how you adjust your weight. Sometimes you need to put your knee up against something, sometimes your elbow up against it, which is why they're looking at, having something which is really a humanoid form instead of some sort of strange little creature with a couple of human arms that come out or robotic arms that go ahead and do tasks. So, because our workspaces are designed for us, it makes sense to make the bots more that way. And at the same time, you have to look at different use cases. So a factory setting, you need to have a little bit of ruggedization to be able to operate in that kind of environment. But in the home, you need to be a little bit softer because you got to remember you're around pets, you're around elderly, you're around children, you're around humans in general, and you want to make sure they're not accidentally injured as the bot attempts to do any work.
Yeah. So do you think that Tesla bot can actually do all this as well? Can it be at the home?
Oh, yeah.
It will be able to be at home.
It should be. And there's no reason why the mass of the Tesla bot couldn't go down. I suspect they're going to be making some pretty big changes in their upcoming versions that will make it lighter and make it more general purpose for, not just being in the factory, but also being out. So my feeling is that they were focused on the factory at first and then realized that the way the design is going and everything else, that it probably will have capabilities that go beyond just in the factory. Just why they keep on talking about it. We'll be selling it to customers beginning of next year. And that was a bit of a surprise that they would be moving that quickly.
So you think that the Tesla bot's perfect? That's like right hit in just a sweet spot.
Yeah, it's got all the capabilities.
Okay,
right. So where you've got to be is you got to make sure you not only have sufficient capabilities, but you got to make sure that you aren't missing capabilities. And so you can't overdo it. You could maybe put too much in there. And then it's like, well, that's too, it's like everyone said, well, why not put a third arm on there or something like that? It's like, well, that's probably a little bit of overkill. But at the same time, if you decide, well, we'll just have a 2-finger hand, well, that's going to limit you in a lot of capabilities, because a lot of human tools, need to have more than just 2 fingers. If you think like you pick up a drill or something like that, you got to have at least a trigger finger in there. So at least a minimum of 3, but still the other 2 are in there because it really helps you to be able to hold that in position in the grip. So there's a lot of reasons for wanting to be able to get as close to emulating humans. And we've seen the normal Tesla philosophy is they took out as many parts as possible, and we're seeing them slowly putting them in. So the neck didn't have any movement. Now it has movement. They didn't have any sensors in the fingers. Now they do. The hand was 11 degrees of freedom. And now for some reason, they've decided to go to 22 degrees of freedom. So as they're doing these experiments, they're beginning to realize what capabilities they need to start putting in, maybe which ones they don't need to put in there as well. So remember, Tesla has a long history of being able to design products that people love to use that really fit the capabilities. And so part of it is a product that we know the customer wants, but also we have to make sure it can be manufactured at scale, which means affordable, and having the quality and everything else. So they know a lot about design for manufacture and also design for excellence. So that's also part of their product design and the psyche of them going in. It's like, okay, it's nice that we can come up with this thing, but how do we make it? How do we make it at scale? How do we make it look nice? How do we make it functional? So that's like one of the huge advantages they have. And then the other advantage they have is the fact that they are their own best customer. So they know what the needs are to be able to do it. And of course, lastly, the other thing is that they've got deep pockets, right? So
Sure.
it's not like there's going to be problems funding.
What I'm saying is that, okay, so it makes sense that that's, the first principle, right? Make it humanoid. But the problem is with the humanoid is that it's not yet humanoid, right? So it looks humanoid. It has the feet, it has the arms, but it doesn't have the flesh. So, I'm a human, you're a human. We can work in a factory, but we can also work at home. I can take care of my mom. But that's because I have, you know what I mean? It's like a perfectly designed that I can hold a big box. Obviously, I'm smaller than other humans, and so you know what I mean. But I can do the box movement, but also I can do the fine movement. So I just worry that I shouldn't worry, but I'm just saying that okay, well, this is the version for the factory. I can see it. The version for the home, I can understand why 1X may design something that could be more appropriate for the home and handling elderly.
And one of the things that might be more appropriate is that if you look around the hip area of the Tesla bot, it's not something you would really want to invite it to sit on your couch.
Yeah.
Whereas, other bots may be designed that if you're actually going to be able to sit down, that they would sit down without causing damage. The same thing would be getting into your car. So again, it depends a little bit of the design space you're looking for and going in, but it doesn't mean it's not something that won't be cleaned up or changed going forward. So I suspect that we could be seeing new designs that make it something that, if it really does want to sit down, which we can see literally sitting in a chair, then is it properly designed for that? And you may want to actually design it to be able to do it, because there's a lot of operations that you need to do that you don't want to be standing the whole time, because standing requires energy. It requires energy for you and me if we're just standing in, if we're not walking. It'd be the same thing for the bot. So if there's actually some activities the bot needs to do and you want to get that excess battery life, well, then you want it to be able to sit down. Now, do I want to have these specially designed chairs just for bots around my house, or just like if it needs to sit down, I want it to sit down on what I've got.
Not ruin it.
So let's not redesign the workspace for the bot. Let's redesign the bot for the workspace.
Okay. Let's ask you a number of other questions. Better understand the Tesla bot. Want to know the battery life. Let's focus on that, for example. So, people can see the Tesla bot here. You'll notice that it doesn't have any backpack. It is like, boom, beautiful. Look at that. The battery somehow fits perfectly into the body. Now, we don't know, right? Unless they've told you how many hours is it? Have they announced that it's a 4-hour bot, depending on what activities it does?
We have an idea based on what they told us from AI Day 2. And there's a lot, some CAD images showing it. So we know that the chest cavity is primarily for the battery pack. And in there, and some other electronics and different things, there's no actuators in there except way up here where the shoulders are. So they've got more than enough volume in there to be able to stick in what is 140 2170 batteries. And it's a 2.3 kilowatt hour battery pack. They stated that. So we know exactly what it is. It's a 52 volt architecture. and with an expected battery life of up to 8 hours between charges.
What?
So we know that, and part of it, it depends upon, how hard it's working. So maximum output's around 500 watts. So if you're going to the maximum output of 500 watts, you're looking about 4.5 hours of battery life before you use up the 100%. But if you have a more average one, which might be around 200, 250, then that 8 hours becomes possible. Now, the other thing, anyone that drives a Tesla knows is that when you go from one charger to another, you don't necessarily always bring it down to 10 or 15%. You might charge it 20 or 25% and just get it up to a little bit, because there's that sweet spot in the charging curve where you could charge really quickly. And it's actually more efficient to do a bunch of short charges than one long one. And be the same thing with a bot. If you need the bot to work for a long day, make sure it starts out fully charged in the morning, run a couple hours out of it. During a standard kind of coffee break, just give it a 10, 15 minute boost. It's suddenly backing up there. You can easily make it to lunchtime or beyond, hit it again, and you're through that. So with a series of small charges during the day, you can easily get 8 hours or more out of it. Yeah. And 1X has already said that that's what their customers want. They say, we only want like 1 hour out of it and like a 5-minute recharge. So they can do that. Now, I think, that's what we know from the Gen 1 bot, what it was. Mm-hmm. I'm assuming they're using the same cells and everything else in there in the Gen 2 bot. And they may be getting a little bit more, because since they came out with that, I think Panasonic has said they're able to get about another 10% out of that battery pack. So it's like, oh, maybe that's like a 2.5 kilowatt hour battery pack now. And then the other thing is like how efficient their batteries are going to be, how efficient the compute's going to be. There's a lot of places that they can improve in that. So yeah, the expectation is that you should get many hours out of it. The other bots are in the order of 1 to 2 hours, but again, using like a charging strategy to be able to go ahead and take care of it. Now, if you look at it from the standpoint of a factory, is like there's also swappable battery packs. There are a few companies that have swappable battery packs. I think Aptronics is using swappable. Others have looked at it and decided against it. Figure looked at it and they decided that they didn't want to use a swappable one. And the way I look at it is, if the bots are cheap enough and you've got a bunch of bots in the factory and they're all basically interchangeable because they all have the same skill set. Yeah. You can swap one bot out like that. Bot so when one is weak in charge, you just bring another one fresh charge and goes. And we do that all the time. That's how humans work, right? Is that sometimes we got to be really working there and we'll be going out. It's like, just go to the swimming pool, right? The lifeguards, it's like every 20 minutes they swap out because they get tired, right? It's pretty hard looking to see, whether there's some swim. So because of that, a lot of times we already have that built into our schedules, this idea you do a swap out. So the idea of the swappable battery pack is like the bot is the swappable battery pack. Yeah. That you're able to move around.
Makes sense. So do you think that Tesla's battery is a competitive advantage, or is it something that other bots can do? So let me just show you, Figure. Mm-hmm. Now, Figure, many people are thinking that they are the competitor to Tesla because they raised $675 million. This is their demo, but look at that battery pack. Now, this is the early versions, but you can see that it's carrying a battery pack, a backpack. Sorry, the backpack is the battery pack, and very likely it's just not their focus right now. He's told us before that the first focus is always kind of the brains, and then they found out that they're able to teach it, learn it. They've got partnership with NVIDIA. They got a partnership with OpenAI. And they've shown that they can train. Then they said, I don't care that the bot is walking slowly because we just haven't focused on it. We're going to now focus on it. Then soon it'll be walking much faster than everyone else or catch up to everyone else. Same thing with the battery pack. I'm sure that they said, let's just put the backpack for now, but we'll focus on that later. Do you think, though, that Tesla is, because of their energy division, like they are the experts, they're one of the leaders, especially since they've already had all these cars since 2012, they've really understand how the hardware, the software, the charging, how it optimizes. Do you think that that's a massive advantage, or is it just, okay, it's a small one?
It's a huge advantage because they know a lot about battery technology and battery management systems. And it goes beyond that. They also know about actuators. So when you look at the Tesla, it's not just about the battery pack in the BMS. It's also about the actuators or the motors that go in there and making sure they're efficient and that they're sort of balanced with the battery pack. So a lot of that knowledge allows them to build an entire system, which is really energy efficient. That's what's going to be important. So they already know how to do that. And so they already knew how to build actuators. So they've got a design department that's able to do it. They have a lot of expertise they can draw on. So that again gives them a huge advantage. And then figuring out exactly the amount of power that they're going to need to be able to run these things. They already know how to simulate things like that. So they've got a good grip on it. Again, looking at Figure, that is their first generation bot. So it's going to be, similar to the Bumblebee in a sense that, it's like really the first one they put together to understand that. I'm sure they'll clean up that design in the next generation. I'm not sure that they would have a battery pack like on there, like a backpack, but it might be more integrated in. But Tesla does seem to have an advantage because when you look at some of the other bots, I'm trying to figure out, well, where are their batteries? Because their torsos seem to be pretty small. And so, they're not packing a lot in there. And when you go to look at their specs, they don't really say too much about the battery life. You have to kind of tease it out. And from what I've seen, most of them, the largest battery packs they might have might be in the order of like 1 kilowatt hour versus the Teslas, which is like 2.3 kilowatt hours. So most of them are maybe 50% at best. Some of them might even be less. Some of them said that you're seeing something like that. And it's like, yeah, it lasts 30 minutes and then it needs to be recharged. So I'm sure they're all going to be addressing that. And again, it goes to this question everyone has is like, well, do the robots even need a battery pack? Can't you just plug them in? And it's just like, it just depends what your use case is. If the use case is the bot's really not going to be moving around, it's going to be mostly stationary, then yeah, sure. Then that makes sense. And then you should only be making the bot from the torso on up. There's almost no need for anything else. But if the idea is the bot needs to move around, then you need to make it wireless, and then to make it wireless, you need to have the batteries. And if you don't, agree with me in that, just go ahead and get, some headsets, VR headset, and get the ones with the wires and start walking around for a while and see how long before you get kind of tired of that cabling system, the management system of that just being a hassle and just getting in the way versus a wired set where you're really free to move around. And that'll be the same thing with the bots, is that if you plug it in, it's going to be kind of awkward for it to do some tasks. You're constantly having to consider what's it doing if it's wrapping itself up. And then induction, I don't think they'll be using induction right away, but that could be something down the future where you're looking at that as a potential way of being able to power your bots. But for now, they're going to be sticking with battery packs.
Okay. Let's talk hands. Thank you for explaining that. That was very thorough. I do think that Tesla's battery will be an advantage, but it's just one of those things people just take for granted. They think that, oh, just batteries. I'll just plug in, just like the cars. All electric vehicles have car batteries. They'll just buy it from the others. But maybe there might be the way it's all coordinated. It's like, my energy, how I'm energetic, and maybe an athlete is much more energetic than me. It could be that difference. Let's talk to hands. So we've heard that Elon has announced that they're going to go to do a 22-degree freedom of hand by the end of this year. Let me just show you the hands here. And then, I love this. I don't know how many times I've showed this. Beautiful hands. Those hands, though, are 11 degrees of freedom right now. And then, but there's a patent here, right? So the new patent application for Optimus hand was published recently. You wanted me to show that. Describes cable-driven fingers that use pivots and springs for stability. Some aspects might carry into the next gen 22-degree freedom hand. So this is pictures that came from that patent. That was one. And these are the fingers. It looks like that there's actually, they're really copying that finger now. There's no longer this, two joints. It's going to be like the three. It's going to have it right there. So tell me what this whole movement to a 22-degree freedom of hand, who else is doing this? What other bots doing this? And why is it this is so important?
Okay. The only other one I'm aware of that probably has 22 degrees or something similar is Sanctuary. So they've already been able to show, this kind of movement here, which is usually called like the abduction of the fingers, as opposed to just this flexion extension where you're able to go ahead and grasp something. So 11 degrees of freedom will really only give you this. And the other thing with the 11 degree of freedom is they took away one of the knuckles. They basically fused these things together. And a lot of them sort of followed Tesla on that and decided to go with the 2 knuckle versus 3 knuckle. Now Tesla's saying, oh, we took out too many parts. We're going ahead and put them in. Now the patent that you have there, it takes a little while for a patent to come through. And it's rather curious it's come through because if you look at it, it's really the hand and the Gen 1. They've already gone to Gen 2. Now the Gen 2 hand is very similar to Gen 1. It looks a little bit nicer than the mechanics that they have in there, but I think the actuation and everything is similar, except they threw sensors in there. So that's one of the other things that they added. But now they've decided to add the extra degree of freedom. And I think that's the pivot going from an industrial application to deciding we want to, be more general purpose and perhaps end up in the home. And so I'll ask you quite simply, Herbert, usually if you're doing some rough work and stuff like that, you wear a pair of gloves, right?
Yeah.
And a pair of gloves kind of limits your mobility of your fingers. Your dexterity is not quite the way it used to be, but you can still do a lot of work with that. And that's typical. What you'd see in a factory environment is that you're going to have some sort of personal protection gear, which is going to prevent you from having full dexterity in your hands, that you're capable of doing everything. So if you think about it that way and you're designing your bot for that, 11 degrees of freedom is good. If you're going to 22 degrees of freedom, you're thinking way more general purpose. Now, what's one of the things that you could potentially do with a 22 degree freedom hand?
Play piano.
That you can't do. Let's say when you take your gloves off, Herbert, and you go in the house, there's a lot of things you can do that was a lot harder to do with your work gloves on, right?
Gotcha.
And one of them would be maybe playing the piano, it's one example. So if you want something to that level, then you need to get that additional movement in there. And now we're guessing at what that movement might be, with those 22 degrees of freedom and how much actuation is going to be in there. And what's nice about the humanoid bot community we've set up on X is that I've been getting in contact with a lot of people that have done hand design, in some cases for entertainment, in movie making, but very similar, kind of prosthetic hands, and looking at the degrees of freedoms that they have there. And it maps kind of to what Tesla is probably thinking of as far as the number that's going to be there, being able to get this movement. And the only question is going to be, will they have the movement synchronized together, or will you be able to do it one at a time? And that's the question of the number of actuators you have, not necessarily the number of degrees of freedom. So we know it's going to have the degrees of freedom to do it, just a question of how much they want to have. And we know we're moving it back here. And that tells me there's a lot of changes going on there, which could also mean that the power consumption may also improve. Now, if we go deep in that patent, there's a lot of other interesting little nuances and things that I was able to pull out that I'm still trying to figure out that were intriguing that they discussed. And that is that part of the reason for this patent seems to be more of a defensive patent than anything else, just to make sure that someone else doesn't say, hey, we came up with that idea before you, and suddenly they have to do the right. So they did that just to make sure that any ideas they came up with, they can use it, and that no one's going to be a patent troll and take it away from them. They probably are going to be using something similar for the actuation of the fingers, and that is using tendons. It appears that they may have already had in the old one a form of censoring that they could be using again, or they may have replaced, because we know now they have fingertip sensors that they put in there. And I was like, well, if you're putting in fingertip sensors, you need now to run other wires and everything else. And I was suspecting that they wouldn't need it, because there's two ways they were able to tell if they're grabbing a bottle. And that is the motors themselves. So the feeling back here, like in your muscles, when you do that, you can kind of feel that grip, as well as you can feel out here, that force. So from the actuators and looking at the back EMF, they would be able to tell when the grasp was really coming down to something hard, and you don't need any sensors for that. And that's the way they decided to roll at first. And I suspected, but they've got those tendons that are going through there. I was just wondering if there's some signal that can run through the tendons in some way. And I was speculating whether they could do something. And this patent almost confirms it, because there's some interesting language they use in there when they talk about how the cabling is attached to the distal, to the very end. It's on page 22 if anyone wants to look at it. And they talk about like a floating end. And I'm like, wait a minute, that's an interesting term of art right there, because in patent, your language has to be very, very precise. And they talked about one of the ends being potted. And again, that's like very clear language. You can go ahead and look up the definition. Is that potted, from the standpoint of engineering, it's an electrical engineering term. It talks about like putting a resistor in. It means doing a form of electrical isolation, not necessarily insulation, that you're trying to insulate that from something else, but you're trying to change the resistance in there to maybe make it easier for you to sense a certain amount of current flow. So I was like, wow, maybe that's what they were doing, and the fact that they talked about like the end that was floating, and I'm like, again, that's like what they usually talk about in double E, that you get like one side where, the field is floating a little bit, and you need to isolate it by potting all this. So it's like, okay, I wonder if they already have a kind of sensory in there that they're piggybacking on top of the tendons they're putting in. And that's something else that we'll see going forward.
Wow. Okay. That's what I wanted to ask you. Questions about the battery, questions about the hand. questions about how it compares to figure, how it compares to digit, how it compares to the 1x who's going to go straight to the home. And as what I'm noticing, which is very logical, which is you start with first principles, which is a
Hmm.
humanoid form, and then you double down on that and you realize it's got to be humanoid form, 5 fingers, 5 digits. And remember how they initially you showed at the very first all the digits were exactly the same size, including the pinky, and
Yes.
then they just offset it. That way, when they make a digit, it's exactly the same digit, and they just like mass produce it in the console
Interchangeable.
below.
Yep.
Now you're suspecting that they're going to change. They're going to actually copy the hands as closely as possible. They've added sensors in. Now they're talking about, like you're saying, tendons and all these right, 22 degrees of freedom. So you need to become more and more and more human as you move forward. And we'll see how, maybe instead of it being steel, maybe there's a different carbon fiber, maybe there's a plastic version that's going to be for the home.
Yeah, and so I think a lot of it is that you want to try to get as close to what the human hand does from the standpoint of robotic control. So that's what they're probably learning is that telling the operator that you can't make your fingers do this is a little bit tricky, and also if the links are off, that's going to also make it a little bit difficult doing certain operations. So they may be realizing that getting that hand movement was much easier for being able to fold T-shirts, for example,
Yeah.
as opposed to always having it this way because that's the way the operators were doing it. There could be other things as the feedback that you get when you grab something. So a lot of times when we pick up something, we'll get a feel of the surface of something a little bit, and we might react to it a little bit different because that's like a feedback signal we're getting.
Immediately, yeah.
But the robot's doesn't have that sensory input that the teller operator is getting. And so that's part of the reasons why you would want to mimic everything as closely as possible.
Yeah.
So keeping the fingers the same count was always important for that reason. Now they might be thinking of getting the finger links to be a little bit more similar, which is my suspicion. I mean, the first thing clearly they're adding the extra knuckle back in because I don't know how you get to 22 degrees of freedom without adding the extra knuckle in. That's a given. The question is how much additional degrees of freedom they may have in the palm or something else like that. But they want to get as close as possible, and the maybe even add something into the neck going forward because they do have some neck movement. They may decide they want to even add one more degree of freedom. You could potentially put 5 degrees of freedom in your head. I don't know that they would go that far. So they'll go from maybe 2 to 3, and you might add something in the torso to make it easier to lean forward and do a few things because they kind of took that out because they used some redundancy in the movement that we have in our kinematics to eliminate things like, you don't really need that because we can accomplish that through movement of another joint. But they're beginning to realize that, that redundancy is going to be important to be able to actually mimic what's going on robotically. So that's where you want to start is you want to get as close to human kinematics as possible.
Yeah. It's, I remember when we spoke to 1X, Bernd Bornick, the CEO there, and what got me excited was when he said, when they studied what you do in the home, sometimes when you're opening up the cupboard, the elbow matters. Like, I don't know, I can't remember what he exactly said, but sometimes you use the elbow in a certain way. And that's why it's so critical because there's all these little things we do as humans that you don't realize is important.
Even the forearm. I mean, think about sometimes when you're leaning over and you're trying to grab in something, you're putting your forearm on the surface and you're intentionally sliding along there to be able to support your weight while your fingers are moving around trying to find that glass that's back there. It's like, I got it. And then you kind of slide yourself out.
Yeah.
So he's right. We've got so many contact points that we're not aware, we don't think of. And then when you begin to study it, you go, that's going to be very important. Now, how do I teach my mechanical being to do that if its dexterity is very different? If it's double jointed or it doesn't have an elbow the way I have, then it's very hard to kind of give it that sense. So being closer to the humanoid form makes it a lot easier, especially if you want to do the initial training set robotically.
So that is a little bit of a shot in the bow there, Scott. You're basically saying that there's some bots out there. We've seen Boston Dynamics and others that are showing off they're double jointed, that they can get up from the ground. And you're saying, well, that's cool, but you may not, may actually be bad. There's a reason why humans have a limit because, right? It's like there's easier, more ability to carry things hard, like things like that.
And then having a 3-finger double jointed hand is also something that's going to be very hard to mimic.
Yeah.
It's just, so even if you're using like training data, which is looking at videos of how people do it, then you got to figure out, well, now how to do the exact same thing with that hand. And then what you'll find out is that in the end, you're not using that double jointedness because humans don't do it. So why'd you put it in there in the first place?
Put in the first place. Okay, we'll see if you are right, or maybe they are right that they gives them, they can move faster. Because one of the things you kept pointing out before was the thing you're looking for in a factory, for example, is how fast these bots can pivot. Because humans can grab a box, and then there's these fancy, hip movement that we do to pivot fast. But these bots currently, because they're, Gen 1, they're like, shuffle, 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 and they turn around. But these double jointed, maybe they can just flip around and whoop, and then there's no front, there's no back. They can just move, They don't even need to turn around. They can just walk backwards, or.
Yeah. It's an interesting approach, and in many ways, if you look at it from the standpoint of an engineer, it's like, oh, that's elegant. I mean, that's really cool. It's like it can turn and move to the destination all at the same time.
Mm-hmm.
There were certain things that I do like about it, but then other things like, yeah, but it's also, very unhuman. And you can either solve it doing that problem, or you can just get the bot to figure out how to pivot really quickly, because we're able to do it as humans already. It's not like we plod the way around. We know there's a solution to doing that, and that we do this nice little graceful pirouette on the balls of our toes when we need to, just come right on around.
It's a good question, though. I mean, you want to copy humans first because they've evolved to be a perfect design, we assume. But then maybe you want to be superhuman. Maybe this is the best design that we just couldn't do. But so let's share that we have created a community on X. So what you do is, if you're on X, previously called Twitter, there's a community tab, and you join this humanoid bots community. We now have over 2,000 members. We literally just started this a week ago. If you've got an interest in humanoid bots and also human scale bots, these are any kind of intelligent agents, join that community. Just a quick click, join it, and then you'll see that we often will post. This is our beautiful table that our Cern Basher, Scott, and I, and John are keeping updated. We compare all of the bot manufacturers. We post videos of any kind of bot news that's coming out there, and we have conversations about it. And that's where you can also find, for example, the patent that's been out there. So
yes,
please join us.
That's the other thing to point out is it's not just about our posts, it's about the posts from our community members. And again, we'd like to thank SETI Park for posting in there the patent that he was able to discover and do the analysis of it. And that's the whole idea of the community. It's not just about us sharing information, but also other people being able to share information, finding what their interests are. I'm learning a lot in that community. And I'm very grateful for the people who posted those things. And so if you're kind of curious to learn a little bit more about human bots, and the other thing is that we enjoy your feedback, because every now and then I try to run a poll to get an idea of what people are thinking about human bots. And so that's also kind of a
Do you
nice
know what you're doing,
go.
Scott?
Go ahead and see that.
You're calling it human bots. So I'll tell the people why. So first of all, these are humanoid bots.
Yes.
But the term human bots is our term because we created a company, Scott Walter, John Gibbs, and Cern Basher and I, called Human Bots. And so if you are a company, you're in any kind of business, and you have different kinds of bots, even if you just have one kind of bot, let's say the security bot, maybe you have a lawnmower bot, maybe you have one of these human bots, call us. And we've got software that we've created now that can help optimize your workflow and your mixed labor optimization that's happening there. And we can integrate with your enterprise software systems throughout your company so that you can actually truly have a unified view of all labor. And you can imagine what's going to happen in the future here. There's going to be an explosion of all kinds of intelligent bots, and all businesses will need to be able to track this unified labor and using AI, simulate what is the best, which bots do you need. Scott is the expert. He has a library of every single bot, but not just the names. He actually knows the specifications, which one can carry what loads, how fast do they move. We can simulate it in your environment. So give us a call for human bots. Scott, you got to stop using the term human bots. It's become Kleenex.
Yeah. That's right. So the humanoid bot community. Yep.
Yeah, there you go. Thank you, guys. Thanks, everybody. Thank you, Scott. Appreciate you taking your time and
thank you, Herbert,
sharing your knowledge. And, we learned a lot more about TESLA Bot and how it compares to everybody. Thanks, everybody. Bye-bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.